Today we're going to go over what selection sort is, and of course this is another sorting algorithm. What is selection sort? Selection sorts by finding the minimum element, this is important, in the array and swapping the minimum element from the unsorted list by putting it at the beginning of the unsorted list. So some key terms. Minimum, it swaps unsorted list or array, putting it at the beginning of the unsorted list. So we are going to have pretty much two parts to our array. And it doesn't mean that we are going to have two separate arrays, but we are going to pretty much cut the array into two, and those two parts are sorted and unsorted. And if you don't get this part right now, I'll illustrate it later after we go over our time complexity just shortly. So time complexity for all of them is O of n squared, and these are the cases. And time complexity for selection sort is all the same. That's because for each and every iteration, we have to go and find the minimum element. And since we do not know the place or the index of where that minimum element is, we would have to, worst case, iterate through the whole array to find that minimum element. That's why it's going to be O of n squared. And O of 1 because we are using auxiliary space for our temporary variable. Now, let's say that, for example, we had an array -2, 2, -1, 1, 0, and 0. So we are handling positives, negatives, and duplicates. Okay, now the first thing I want to do is find the minimum element. So I'm going to iterate through my array and find the minimum element. And minimum element happened to be -2, right? And when I say minimum element, I'm actually more concerned about the minimum index. So the index is 0 for now because I want to swap those two numbers using indexes, right? And the second part to our definition was that there is a unsorted list. So when we begin our selection sort, this whole array is going to be unsorted. And as we are sorting our elements by swapping them, it's going to have two parts, again, sorted here and unsorted. Since -2 happened to be the first element or the minimum element, we actually don't have to make any swaps. We can just leave it here. So that's going to yield us -2, 2, -1, 1, 0, and 0. So this part is sorted. This part is unsorted. Now, what is going to be the beginning of our unsorted list is going to be this one, number 2. Now, we're going to iterate through our array again. And obviously, when I say array, it's the unsorted part of the array. And we are going to find our minimum element, and minimum element happened to be -1. So what are we gonna do? We're gonna swap -1 with the first element in the unsorted array, which happened to be the number 2. So that's going to give us -2, -1, 2, 1, 0, and 0. And again, this is sorted and this is unsorted. Do you see the pattern now? Now we're going to look for our minimum element again in the unsorted array, and it happened to be 0. And what do we want to do now? We want to swap. We want to swap with which one? The first element in the unsorted array. So that's going to yield us -2, -1, 0, 1, 2, and 0. Again, we repeat the process. Minimum is 0, and we sort it up to here. We're going to swap this one with this number 1. And we get -2, -1, 0, 0, 2, and 1. Finally, we want to check again. Minimum is 1, so we swap these two numbers. And as a result, we get our finally sorted array. Okay, so big picture overview of selection sort. We want to find the minimum index, replace it, or actually, better than replace, swap with first element in the unsorted array. You want to repeat this until all elements are sorted. And finally, we want to return the array. So just to give you a tip, we are actually going to have nested for loop where the inner loop looks for the minimum min element, exactly the index. And obviously, the outer loop is going through the whole iteration of this whole operation that we did. If you guys find this helpful, make sure you guys like and subscribe. Thanks. Now let's go over our first solution, and I have my pseudocode here. You can try it without the pseudocode. That would be really good. If not, read the pseudocode and then try it. If you still don't get it, you can come back to this solution and look at how the code or selection sort works. First thing, I want to create a function that takes in a parameter array. Next, I'm going to create a swap function. We did this many times, so I'm just going to leave it here. Next, I want to iterate through my array to sort and compare the elements. And in that loop, I want to declare another variable called min_index and set it equal to the first index of the unsorted array. And if you remember, we are going to have two parts to our array in our selection sort. First one is sorted and next one is obviously unsorted. Next, I want to make an inner loop to iterate through my array, and this inner loop is simply looking for the minimum element in our array. And I'm going to start at index i+1. Why am I starting at index i+1? Well, remember, I am setting min_index to the first index of the unsorted array. So for our first iteration, it's going to be -3, right? And when I want to look for that minimum value, I obviously don't need to look at this anymore. And that's why I want to look at the elements to the right of the first one, first unsorted element. And I'm going to check, well, is my current element less than the element that's stored at min_index? If that's not the case, I want to overwrite min_index to my current index. And finally, I want to check, well, is the element at min_index less than the first element in the unsorted array? If that is the case, I want to swap. And one key thing to note is that I actually don't need this if statement. It will still work, but having this if statement allows us to avoid unnecessary swaps. Well, actually, let's go back to our array. Well, -3 happened to be the first number in our unsorted array, and it also happened to be that this was the minimum value in our whole array. Do we need to make a swap? No, right? Because -3 is already in the correct place, so we don't need to make any swaps. And finally, I am going to return my result. Now let's start coding. First thing I'm going to do is I want to iterate through my array to compare and sort elements. And I want to increment by 1. I want to make a variable named min_index and set this equal to I, which is the first element in our unsorted array. Next, I want to iterate through my array again. And this is going to start at index i+1. Well, why is it i+1 again? Well, my min_index is already set to I, so I want to look at right of the first unsorted element. And this is going to be less than j is less than array.length. And let's increment j by 1 each time. Looks good. Now I need to check if my current element is smaller than the element at min_index. So if array at index j is less than array at min_index, what do you want to do? We want to override our min_index and set it equal to that current index. Finally, I want to return my array, but we're not done yet. I want to check, this is our final check. If array at min_index is smaller than array at I want to obviously swap, pass in min_index, and then I. And finally, we get our result. Just to show you a different way, we talked about how we don't really need that if statement. And as you can see, it gives us the same result. I don't want that because I just want to check. Well, this is being more precise. So let's be more precise. So this is our final result. Now let's go over our code just one more time really quick. First thing, I'm iterating through my whole array. I'm setting the first element of unsorted array to min_index, and I'm iterating through my array again, but this time to the right of my first element of the unsorted array, and I'm checking, and I'm saving that min_index to my variable. So I'm gonna loop through, I'm gonna look for the minimum element and save that index to min_index variable. And finally, I'm checking, well, is my element at min_index smaller than my current one? Well, if that is the case, I am going to swap. Otherwise, I'm just gonna skip this and then just loop through this one more time. Finally, I return my result. Okay, it looks good. Now I want to just show you one more thing. Let's console log array slice 0 to I, and then I'm going to console log also I+1. I actually console logged above my if statement. I think this illustrates it a little better. So I have two arrays. One is empty and one is full. And obviously the second one is our original array that we have. And if you remember, selection sort has two parts to our array, right? And first one was sorted and the second one was unsorted. As you can see here, this one as sorted array and the second one as unsorted array. And our second one is exactly same as our first initial array. And as we loop through, -3 is going to be in the correct place. So it became the first element and it's in our sorted array. And if we look at our unsorted array, now -3 is gone and we have everything right of -3. And then next iteration, we are going to sort -2 because that happened to be the smallest number. And we are putting -2 at the first index of our unsorted array. So we are swapping 3 with -2 and -2 becomes sorted and we have rest of our array here. And we are going to do that till we reach all the elements in our array and we are gonna keep comparing and sorting our elements. And as you can see, our unsorted elements or array gets smaller and smaller. Our sorted array gets bigger and bigger and bigger. And finally, we are going to have, well, this is not printed here, but all the elements sorted on the left and empty array in our right side. So this is selection sort. Two things to take away from this is that one, there is a sorted and unsorted portion of the array, and you want to put the sorted element to the beginning of the unsorted array. Or you can think of it as pushing it to the end of the sorted array. I mean, they're both the same thing, but I think it may be a little hard to see. So just think about this code just a little while. And second thing to take away is that the inner loop just simply looks for the minimum value and it's storing that minimum index. And finally, we are checking if that minimum element is actually smaller than our current number or the first element in our unsorted array. And then we swap. But you actually don't need if statement over here. You can just do swap. But this if statement ensures us to avoid unnecessary swaps. Now let's go over our second solution, and obviously the logic of this second solution is going to be the same as our first one. But this one is going to use a helper function, and that helper function, what it's going to do is it's going to find the min index for us. But other than that, the code itself is pretty much the same. So try to go read it through the code, and if you don't get it, come back to the video. First thing I want to do is I want to make that helper function. So const find min index, and it's going to take two parameters. Well, why is it going to take two parameters? Well, obviously it's going to take our array and it's going to take something called starting index. So I want to create another variable and set that equal to start index. And if you remember from our previous code, we set min index to I, right? And in our code later, we are actually going to pass in I as our second element. So I want to iterate through my array. So let I is equal to start index plus 1. It looks familiar to our previous code, array.length and increment by 1 each time. So start index is going to again represent pretty much I. And if you actually change start index to I and just change I to j, it looks exactly the same. And now I need my if statement. If array at index I is smaller than array at start, actually not start index, it should be min index. I want to reset my min index to I. Okay, and finally I want to return that index. Okay, now we are done with our find min index. So this one simply is pretty much the same thing as our inner loop where it finds the minimum index. Now the rest of our code, I want to loop through my array. Let I is equal to 0. I is going to be less than array length, increment I by 1 each time. Now I want to create another variable called min index. I'm going to run this function, find min index. I'm going to pass in my array and pass in the index. So I spelled something wrong here. This should be capital I. It looks good. Now we need our final check. So if array at min index is smaller than array at I, which is our current number, what do you want to do? We want to swap. We are going to pass in array min index, and finally our current index, and we are almost done. Let's finally return our array. As you can see, we got our sorted array. Well, is this easier to read or actually harder for you? For me, I actually prefer the first solution. It's more intuitive for me. This one, I guess some of you guys will find it more helpful. Some of you it might be more confusing, which is the same for me. But know that here we are breaking up our operation into two. And this one, again, finds the min index. It stores that minimum index to this variable. And then we are checking if our element at minimum index is smaller than our current one. And if it's the case, we are swapping. And finally, we return our array. Now let's go over our third solution. And this one is going to differ because we are going to use higher order functions to be specific, slice and reduce to make our solution. But overall logic obviously is going to be the same as our two previous solutions. First thing you want to do is create a function that takes in a parameter array and create a swap function. So we have that over here. The next thing you want to do is iterate through the array to compare and sort elements. So up to here is pretty much the same. Next thing I want to do is I want to create a variable named min index to obviously find the minimum index. But we are going to use slice, and slice is going to take I plus 1. Well, why is it I plus 1? Well, if you remember, let's say that our current element is -3, and we want to find the smallest element in the array. We want to look at the right of our current index. That's why we're doing I plus 1. Find the min index in the subarray. So this is obviously going to be our subarray, which is right of the current index, which is 0. So this ensures that we don't look at the elements in the sorted list or the first one. Next, we are going to use reduce. So reduce is going to work something like our for loop, and that's going to take 3 arguments. First one is accumulator, second one is the value or the current value, and last one is the index. And if you don't know how reduce exactly works, I think you should look it up. But our accumulator is going to be set to I. And if you remember from our previous codes, we let min index initially equal to I. So that's doing the exact same thing, just different code. And next, we are going through unsorted list, which is represented by slice I plus 1. And next, we check if our current element is less than the element at our stored index, which is represented by accumulator. If that is true, we are going to add j plus I plus 1. Where did that come from? So j represents current index of the unsorted array. I represents the number of items in the sorted array, and we add 1 because unsorted array will start at index is equal to 0 again. And if this kind of confuses you, I'll explain it as we code. And if not, we are going to keep the current accumulator or index. And finally, we check is the element at minimum index less than the first one. If it is so, we are going to swap. Finally, return our array. So let's start coding. First thing, I want my loop let I is equal to 0. I is going to be less than array.length and increment by 1 each time. And I want to return my array later. Okay, looks good. Next thing I want to do is I want to create a variable called min index. And like always, this is going to store the minimum index that we find in the unsorted array. Next thing I want to do is array.slice. Actually, let's make it array.slice. It's going to be I plus 1. And actually, let's make this code a little cleaner. I'll make it something like this and move this over here. Now reduce. Reduce is going to take 3 arguments: accumulator, current value, and the index. And what did we say? We said that it's going to have a initial value of I. And we also said that accumulator or our reduce function is going to have value of I. And remember that accumulator is our index. It represents our index, and that's going to be represented or have an initial value of I. And we need our if statement here. So what do you want to do? We want to check if our current value is less than array at our accumulator, which is index. And if that is true, what do you want to do? Well, we have it right here. If that is true, we are gonna add j plus I plus 1. If that's false, what do you want to do? We want to return our accumulator. Okay, this looks good. And finally, we want to check if our array at min index or element at min index is smaller than our current one. What do we want to do? We want to swap, and we're gonna pass in our array min index and I, and this should be up here, I bet. And as you can see, we got our result. We have our sorted array. Now let's go over this whole solution. I think the confusion should come from this min index. Our outer loop is the same, our if statement is the same, we return array obviously. So how is this working? How are we finding our min index? Okay, let's console log few stuff. So console log, same as before, what we're going to do is array.slice 0 to index I, and array.slice, we are going to do I plus 1. Now, if you look at this, it looks like what we had before, right? So the left represents the sorted array and the right represents the unsorted array. And if you look here, we did array.slice I plus 1, right? So this array is going to represent whatever is right of our current index, which is I, which is 0. So 0 plus 1 is going to be 1, right? So slice is just going to look at this part of the array. So it's basically cutting the right part, and then reduce is just iterating through just this part. It's not looking at the first one. So accumulator is set to I, and if you remember, what we did before is we set min index to I when we coded our other solutions. So this is pretty much doing the same thing. So right now index is, or accumulator is set to I, which is 0 for now. And then we do our if statement. Well, value is going to represent our current value as it iterates through our array. So first is going to be 3, -2, 2, -1, 1, 0, and 0. And this is going to check if array at our index is smaller than our current value. And this is the process where we check if our current value is smaller than our saved element at min index. So if that's true, we are going to save that index, j plus I plus 1. If not, we are just going to keep that index, which is I. Now the hard part, why is it j plus I plus 1? Well, first of all, to explain why is plus I, it's because, well, if we were to cut our array by I plus 1, it's going to have less and less elements, right? As you can see here. So our unsorted array gets smaller and smaller. And in order to get the correct index, you have to add number of elements in our sorted array. So that's why we are doing I plus or plus I. We're adding I. And j is obviously going to give us our index of the unsorted subarray, or the array to the right of our index. Now, I think we got these two. We know why it's j plus I, but why do we have to add 1? So say that, again, our index was at 0, so I is going to be 0. We are looking at this part of the array. And let's say for next iteration, we want to find the minimum element of this over here. And our I is going to be 1. And if it's 1 plus 1, we are looking at this array. So we know that I is going to be 1. And also our minimum index is going to be 0, right? Why is it 0? Well, -2 is the smallest number in our unsorted subarray, which has an index of 0. So if you're looking at only this array, -2 is obviously the first element. Well, if you were to add I plus 0, that would give us an index of 1. Well, is -2 at index of 1? No, it's not. It's at index 0, 1, and 2. So that's why we add 1 to our array. And I kind of wrote it here, add 1, because the unsorted array will always start at index 0 again. So when we cut this again, or like this, index 0, the first element is always gonna be index 0, and our sorted array only gets bigger. So that's why we are adding the number of elements that we already threw plus our current index plus 1, because we are missing that one extra index because we again start at index 0. So that's the reason why we do this operation. But everything else I think should be pretty straightforward. This solution is obviously the hardest to understand, but if you get it, I guess it's relatively easier to see how things work when we use higher order functions. Now, finally, let's go over our time complexity. We did kind of talk about why it was the case for O of n squared, but now that we know exactly how our selection sort works, we should have a more stronger grasp of why best, average, and worst is O of n squared. Well, let's talk about the O of n squared, the worst case first. And the case is if the array is ascending order when we want descending order. So we would have to literally swap everything. And I mentioned swap is same for all cases because at every iteration, we need to find the minimum element. We do not know where the minimum element is until the end of the array. So if we were to look at our example 1, let's get rid of our console logs. You can see that there is really no like optimizations that we can make. So regardless of what type of array we have, we would always have to do this in a loop regardless of how the things are ordered. So even if it's in order, pretty much we would have to do this many number of operations. So best case in our case would be if the minimum element is at the first index of our unsorted list, but even if that is the case, we would have to iterate through the whole thing again to check if that first one is really the minimum element. I mean, we know that by looking at our array, but how does the computer know that? It doesn't. It has to iterate through the whole thing. And we would have to do that for every comparing and sorting of our selection sort. So that's why it's going to be O of n squared. Now, let's talk about our best case. So when array is sorted, it's still O of 2. And the reason is because we would have to iterate and find min element regardless. So best is also O of 2 because even when it's sorted, we would still have to iterate and find the minimum element. We might not swap, but we still have to iterate and again find the minimum element. Now, as for space complexity, it's O of 1. It's because we only need auxiliary space for our swap function. And if I had a temporary variable, that would be extra space that we need. So if you remember the other version of our swap function, it had let temporary equal to the current element or element at index 1. And then later we use that to overwrite our second element. And that's the reason why we had space complexity of O of 1.